Bismillahirrahmanirrahim. Last time we have discussed atomic structure, right?
Yeah.
This is, yes. We have discussed different questions, how to find relative atomic mass, right?
Yeah.
So we have discussed now. Today is lecture number 4. Okay. Can you define, first of all, I would like to ask you a question. Can you define what is relative atomic mass?
Sorry, sir, could you
Yes.
repeat your question?
Yes. My question is that, can anyone tell me the definition of relative atomic mass?
The relative atomic mass refers to the mass of an atom compared to that of a carbon-12
Mhm.
atom.
Okay, very good. Very good. Can anyone else?
Yes, sir.
Just can you repeat?
So you're asking the definition of atomic mass?
Relative isotopic mass for you.
Okay. It is the mean mass of an isotope relative to the 1/12 mass of a carbon on a scale where the carbon exactly has 12 units.
Exactly 12 units. Very good. Very good. So relative atomic mass is a mass which is compared with carbon 12, right? So today lecture number 4. Now next question. Find the number of find the number of peaks. Peak means bar in mass spectrum. In mass spectrum. Find the number of peak in mass spectrum. So mass spectrum, or you can say that peak. Peak means lines or bar in mass spectrum. Mass spectrum. For example, this is the graph. Here we have mass over charge ratio. Here we have percentage abundance. So these are peaks or lines. These are called lines. Lines. Now, question number 1. Question number 1. Hydrogen. Hydrogen. Yes. Can you tell me how many isotopes does hydrogen have? Last time we have discussed
3 isotopes. Right? 3 isotopes, right, sir?
3 isotopes, correct. 3 isotopes. H1.
H2 and H3.
Exactly, H2 and H3. We have 3 isotopes. We have 3 isotopes. For hydrogen 1 positive, this is mass over charge ratio. This is mass over charge ratio. For H1, Mass over charge ratio is 1. For H2, mass over charge ratio is 2. For H3, mass over charge ratio is 3. So how many peaks? So we have 3 peaks. First peak at 1, second peak is at 2, third peak is at 3. No need to draw the mass spectrum. Now question number 2. Chlorine positive. Now can you tell me how many isotopes for chlorine? Yes. Anyone? How many isotopes of chlorine?
So does it have two isotopes?
2 isotopes, 35 and 37. So mass over charge ratio, 35 and 37. So it has 2 peaks. These peaks are called atomic peaks because hydrogen is atom, chlorine is an atom. Now third, Br positive. So Br positive, how many isotopes for bromine?
Two isotopes.
2 isotopes, 79, 81. So you have again 2 peaks, peak at 79, peak at 81. 2 peaks. 2 peaks. Now question number D. Cl minus. Yes. Can anyone tell me how many peaks? Now you have Cl minus. Yes.
Sir, won't there be two peaks as well?
Sorry.
Won't there be two peaks as well?
Okay. Anyone else? Mohammed, can you
Probably peaks.
yes?
2 peaks, right? It's the same thing.
Okay. 0 peaks. 0 peaks. 0 peak.
Oh, right.
Because 0 peaks because we consider only positive ion. Because only consider positive ions in mass spectrum. In mass spectrum. Okay, next. Now, E part. Bromine. Yes. Can anyone tell me how many peaks?
0, right?
0. Why 0?
Because it's negative.
Because, no, it is not negative. Bromine, there is no charge, neutral.
All right.
0
No
peak.
charge.
Very important with respect to paper 1. 0 peak because neutral atoms are not considered in mass spectrum. In mass spectrum. Now, note H positive, Cl positive, Br positive, all gives atomic peaks because they are atoms.
Aren't they ions, sir? Like H plus, Cl plus, and B
Or
plus.
you can say that ions, right? Single element ions, right?
Okay.
Single element ion. Single atom or ion. Because you know that H2 is molecule. Now, question number F. H2 positive. Now, H2 positive means it is a molecule. So, hydrogen. You know that hydrogen has three isotopes, H1, H2, H3. So, your first combination is 1, 1. So, mass over charge ratio is 2. Second combination is 1, 2. Mass over charge ratio is 3. 1, 3. 2, 1. 2, 2. 2, 3. 3, 1. 3, 2. 3, 3. So mass over charge ratio is 2, 3, 4, 3, 4, 5, 4, 5, 6. Now, can you tell me number of peaks? Yes. Yes. Can you tell me number of peaks?
36.
Are you listening? No, number of peaks.
Oh, number of peaks. 1, 2, 3,
Yes.
4, 5, 6, 7, 8, 9. 9?
9. Now look at here. At 2, you have 1 peak. At 3, you have 2 peak, second peak. At 4, you have third peak. At 5, you have fourth peak. At 6, you have 5 peak. So 5 peaks.
Oh, right, 5 peaks.
5 peaks. These are called molecular ion peaks.
Molecular. Wait, sir, how did you calculate the peaks? So you did mass over charge, right? So for the first one, it's H plus and then H1. So that's 2.
No,
So
no,
can
no.
you just
It
go
means
about it again?
no. Now listen. This is positive ion, right?
Yeah.
So you have different combination for hydrogen. If different combination of hydrogen means you have 2 hydrogen, right? So one may be 1, first hydrogen may be 1, second hydrogen may be 1. So molecular mass is 2. First hydrogen may be 1, second hydrogen with H2. So the molecular mass is 3. Are you getting my point, Mohammed?
Oh, okay, yeah. Now I do.
Okay. Because you have 3 isotopes. So if H1 plus H bonded with H2, it means total mass is 3.
Could you do the same thing with chlorine?
Yes, we have a lot of example, right? Now,
Yeah.
G, Cl2 positive. So you have chlorine bonded with chlorine. Here you have mass over charge ratio. So, you know, chlorine has two isotopes, 35 and 37. So 35 with 35, 35 with 37, 37 with 35, 37 with 37. So 35 plus 35 is 70. This is 72. 72. This is 74. Yes, tell me how many peaks?
3 peaks, 3 molecular peaks.
3 molecular ion peaks, right?
Yeah.
This is number 1. This is 2. This is 3. So 3 peaks. 3 peaks. Now G. Br2 positive. You know that bromine has 2 isotopes, 79 and 81. So bromine, mass over charge ratio. So first combination is 79-79. Second is 79-81. Then 81-79. Then 81-81. (158), 160, 160, 162. So 1,
3 again.
again 3. So 3 molecular ion peaks. 3 molecular ion peaks. Now next is HCl positive. Now it's your turn. Now it's your turn, right? So can you tell me how many possibilities for HCl?
Hydrogen with chlorine. So,
You
so
know that
there's going to
hydrogen
be
has 3 isotopes, chlorine has
chlorine
2
and-
isotopes.
yeah, so it's going to be like 1 with 35, 2
1
with
with
35,
35, very good.
3 with
Or
35,
okay, 2 with 35, 3 with 35, very good.
then it's going to be 1 with 37, 2 with
Very
37,
good.
3 with 37, and then it's going
Very
to
good.
be yeah, I think that's it.
Okay. So this is 36, 37, 38,
38,
38,
39, and 40.
39, and 40. So how many peaks?
5 peaks.
5. 1, 2, 38, 3. This is 4. This is 5. So 5 molecular ion peaks.
Yeah.
5 molecular ion peaks. Now next is HBr positive. HBr, mass over charge. Yes, again tell me.
HBr. So 1, 79, 2, 79, and then 3,
179.
79, and then
Very
1,
good.
81, and then
Very, very good. Mashallah,
1,
mashallah.
3, and 81.
Mashallah, mashallah. So 1 with 81, 2 with 81, 3 with 81. So this is 80. This is 81. This is 82. This is 82, 83, 84. Now, how many peaks?
Around 5 again, sir.
4, 5. 5 peaks. 5 peaks. Now, next. Cl Br positive. Yes. Anyone?
Uh, that is going to be Cl and Br plus. Wait, sir, I have a question. So,
You,
why is it
Mhm.
that you write the positive after the Br and not the Cl?
Because ClBr is a molecule, right?
Okay.
Just like Cl2, this is a molecule. Chlorine is covalently bonded with Br, and the positive sign is over both of them.
All right. Okay, I got it now.
But simply we can write just positive, right?
But sir, how does Cl turn into positive? Isn't Cl supposed to be Cl minus?
No. You can say that each and every ion can be positive, can be negative. It depends on the nature of the electron.
Yeah, but
If any species donates its electron to any species, so donor become positive, acceptor become negative. So here ClBr is covalently bonded. One electron is short in this molecule. That's why positive sign
uh,
is over ClBr.
so that means that like one electron is being lost by both of them.
Yes, one electron is being lost from any one. From the
Right.
molecule, you can say that.
Okay, I got it.
Yes, can
So
you tell me?
it's going to be 3579,
Very
and
good.
then 3779, and then 3581, and then 3781.
Very good. Very good. 3579, 3581, 3779, 3781. So 9 plus 5 is 4, 14, 114, 116, 116, 118. So how many peaks?
3, sir. 3 page.
3. Again 3. So 1, 2, 3. So 3 peaks. 3 peaks. 3 peaks. So note H2 positive, HCl positive, HBr positive, ClBr positive, give molecular ion peak. Molecular ion peaks. Any question regarding these number of peaks?
No,
No,
sir.
sir.
No,
Question.
sir. Alhamdulillah, Alhamdulillah, Alhamdulillah. Everything is clear?
Yeah.
Yes, sir.
Alhamdulillah. Now, beta, next question. Identify following peaks in HCl mass spectrum. Peak number 1, 35. Peak number 2, 37. Peak number 3, 38. Peak number 4, 39. Yes. Now tell me, in mass spectrum of HCl, you have 35 peak. Can anyone tell me this 35 belongs to which species?
H minus and then Cl plus.
No, H minus. There is no
Oh,
minus.
sorry. It can be H0 or H neutral.
H0 means there is no uh,
Charge,
proton
right?
number.
Yeah.
If there is
Wait, wait.
no,
No, yeah,
okay,
then that's not possible. Then how
it's
does
it
it become
it's
35?
so it means it has Cl positive. HCl break, HCl break, and chlorine is released. So mass over charge ratio is 35. 35 belongs to Cl35 positive.
Then what happens to the hydrogen, sir? Why is there no hydrogen atom?
Hydrogen is still in the container.
Oh,
Still
okay.
in the container, right? Examiner
Right.
asked about only 35, not 1, not 2, not 3, not 36, right? Not 40. Examiner asked only about 35. So 35 is due to chlorine 35.
Okay.
Now second question. If mass over charge ratio is 37, yes,
That's 35 plus 2, or the 35 plus 2.
exactly, very good. Your first answer is correct. It is because of the chlorine 2, hydrogen 2, and chlorine 35. Whole charge is positive. Correct. You have another option for 37. Yes, can you tell me?
Another option,
Yes, you have another option for 37.
there's only H37, sorry,
Oh,
Cl37 released,
mashallah,
hydrogen is not
mashallah,
released.
mashallah, mashallah, zabardast. Very good. This is chlorine 37. Very good. So chlorine 37 is atomic ion peak or ionic peak, right? And HCl is molecular ion peak. Now question number 3. Mass over charge ratio is 38.
This can have two possibilities. So it can be 35
Okay.
with the 35 with the 3H, and then,
Wow.
or it could be 37 with the 1H, or H.
Oh, mashallah, mashallah. Correct answer. Correct answer. Correct answer. So you have two options. First for hydrogen 1, chlorine 37 with the positive charge. Second option is hydrogen 3, chlorine 35. Very good. Now the
Sir,
last one is, yes.
sir, what about 40? Aren't there 5 peaks for HCl?
Yes,
And
you have 5 peaks, but examiner asked about 4,
oh,
right?
okay.
It depends on the examiner. So mass over charge ratio is 39. Now can you tell me how many options again?
Sir, over here it should be 37 Cl and 2 hydrogen.
Very good, 39. Very good. You have two options or only one option?
Only one option.
Only one option. So only one option. Hydrogen 3. Hydrogen 3 or
No, sir,
2.
hydrogen 2. Hydrogen 2,
Hydrogen
sir, I
2
said.
and Cl37. So this is all about number of peaks, right? Now, next question. Remember, we are trying to learn chemistry with respect to paper 1 and with respect to paper 2, right? So paper 1, you know that paper 1 is based on MCQ. So few questions are based on MCQ. and few questions for paper 2. Now, question: define A part isoelectronic. Yes. What is isoelectronic? Bete, iso means same and electronic means electron. So atom, ion or molecule. Or molecule having same number of electrons. Having same number of electrons. For example, CH4, neon. Yes. Can you tell me how many electrons in carbon? Yes. Can anyone tell me? Yes.
Carbon's proton number is 6, right? So that's 2
6.
electrons. Yeah. So
So
it has
carbon
4
has 6
electrons.
electrons.
Yeah. So 4 in its outer shell.
And 4 for hydrogen, right?
Yeah.
So total electrons 10.
10.
And how many electrons in neon?
Neon, I believe it also has 10.
10. So both have 10 electrons. So CH4 and neon are isoelectronic because they have same number of electrons. This is very important in respect of MCQ. Next is isotonic. Tonic means neutron. So can you tell me the definition of isotonic?
So atom,
Yes.
ion, or molecule having same number of neutrons.
Having same number of neutron. Correct? Neutrons. For example, boron 12.5, carbon 13.6. Yes. How many neutrons?
So 7.
12 minus 5, 7, correct. How many neutrons? 13 minus 6?
7.
7. So it means boron 12.5 and 13.6 are isotonic. Why they are isotonic? Because they have same number of neutron. Same number of neutron. Same number of neutron. C is isoprotonic. Protonic means protons. So what is the definition for isoprotic or protonic?
We're having the same number of protons, right?
Having the same number of protons. protons. For example, chlorine 35, 17, chlorine 37, 17. Here we have 17 proton. 17 proton.
Sir, isoprotonic is only possible with isotopes, right?
Yes, exactly. Isotopes are isoprotic or isoprotonic. So chlorine 35 and chlorine 37 are isoprotonic. So next statement would be isotopes are isoprotonic. Isotopes are isoprotonic. Okay. Now, next question. Find number of electron, proton, and neutron. Find number of proton, electron, and neutron. First question is OH negative. Yes. OH negative. Second question H2O. Third question is H2CO3. Fourth question is CO3 2 minus. Yes, can anyone tell me how many electrons does oxygen have?
8.
8. So first, always remember, always find proton first. Always find proton first. 8. And how many hydrogen? And how many protons in hydrogen?
1.
1. So total 9.
Yeah.
So whenever you have negative charge, it means subtract or add 1 electron.
Add an electron. So 10.
Add 1 electron. So 10. So always remember, first find the number of proton. Then look at the charge. If negative charge, then add. If positive charge, then subtract. Now, neutron. Can anyone tell me how many neutrons does oxygen have?
8.
8. 8 neutrons, right? And hydrogen?
It depends, but in like the standard one, I think it's one
Standard
neutron.
one. Standard one.
1 neutron.
No, hydrogen does not have any
Zero
neutron.
neutrons, right?
Sorry, 0 neutrons. Yeah.
0 neutrons. Yes.
Yeah. Right.
What are you saying?
Yeah, 0 neutrons. So it's 8.
0 neutrons. So 9, 10, 8.
Mm-hmm.
Now next is H2O. So first find electron, proton, or neutron?
Protons.
Protons. Yes, protons. So
Hydrogen has
how many
2.
protons? 2.
2.
And oxygen?
8. So that's
8.
10.
So 10. So there is no charge.
So 10 electrons.
So 10 electrons. Neutrons.
Uh,
Hydrogen 0.
Oxygen is 8. So it's 8.
8. There are so many questions in MCQ, right? In paper one, you have different questions, right? Sometimes examiner asks which species has same number of electron, proton, and neutron. 4 options are given. In another question, examiner asks Which species has more electron than proton? Are you getting my point?
Yes, sir.
Okay. Question number C. First find the proton. Yes. Hydrogen.
Two protons.
Hydrogen, two protons. Carbon,
Carbon are six, right?
six proton. Very good. Oxygen,
Oxygen would be 3 multiplied by 8, so 24.
24. Correct. So total, I think 32.
Yeah,
Yes.
Okay. So there is no charge. So how many electrons?
32.
32. Neutrons, yes. Hydrogen,
Nil.
Zero.
0.
0. Very good. Carbon,
6.
6. For one oxygen,
8.
There's
8.
24.
24. So it's been 13.
Yeah.
Now next, first proton. Yes, for carbon,
6.
6. For
And
oxygen,
oxygen
8 times 3.
24.
So 13. So here you have 2 minus 2 charge. Minus 2 means plus 2. So 32 electrons. Neutron, carbon has 6. Oxygen has 8. So again 30. Now question number 5. NaNO3. Yes. Yes. Can anyone tell me how to solve?
Sure.
First write the electron or proton.
Protons. That's going to be 11 plus
11 plus
7 plus 24.
7 plus 24. So total
Wait.
would be 42.
Yeah.
And what about the electron?
No charge, so it's going to be 42 as well.
42. What about the neutron?
As for the neutrons, it's going to be so 12 for sodium,
12 for sodium,
plus for nitrogen, it's going to be 7, and then for
7,
oxygen, it's likewise 24.
24. So it would be, I think, 43. Am I
Yeah,
right? Okay.
yeah.
Okay. Alhamdulillah. Very good. Now question number 6. CH3 COO minus.
Right, so for protons, carbon is going to have 6, hydrogen is going
6.
to have 3.
6, right?
Oh, no, you can
6.
just write 12 because there are 2 hydrogens. You can just do
Okay.
12.
So we can write 6 times 12, 6 times 2,
Yeah, and then 3.
3 times 1, correct?
Yeah, and then for oxygen, it's 2, so it's going to be 16.
Okay,
Yeah.
16.
Mm-hmm.
So 8 times 2, all right?
Yeah, 8 times 2, which is 16,
8 times
ideally.
2 is 16. So total,
So 16 plus 12 is
so
20,
2 is
31.
12, 31. Very good.
Yeah.
So here you have minus 1 charge. So add
Yes,
1, 32.
32.
So neutron,
Neutron is going to be 6 times 2. No, sorry, yeah,
6
6 times 2
times,
is 12.
yes, 6
And
times 2,
then 0, and then
0 for
plus,
hydrogen,
yeah, and plus 16, which
8
is in
times
this
2,
case,
16.
29.
So 29.
Well, it's going to be
29 or
28.
28?
28,
28,
sorry.
28, 28. Okay.
Mhm.
So be ready for such type of question in your paper 1. This is for paper 1. Now we have completed subatomic particle, right? As we have discussed, we have 3 sections. As we have discussed, we have 3 sections. subatomic particle. Subatomic particle we have discussed. Now our second topic is electron. This is all about now next is electron. Electrons. Yes. Can anyone tell me the position of the electron?
So in the shells,
Position is
orbiting
in
the
the cell.
nucleus.
You know that electrons revolves around the nucleus, right? So first
Yes.
point is electrons revolves around the nucleus. Around the nucleus. This is your first shell. This is your second shell. Here you have third shell. So electrons revolves. Electron revolves. So this is called orbit. This is called orbit. This is called orbit. This is called orbit. Now I am starting with the orbit. Yes, can anyone tell me what is orbit? Yes.
An orbit refers to the path an electron takes to rotate around.
But you have to add imaginary part. There is
Okay.
not a particular path. This is imaginary part.
Okay.
Scientists imagine that we have an imaginary path where electron revolves. There is no road on which electron revolves. This is imaginary path, right?
Yeah,
So
right.
first point is orbit is an imaginary path. Where electrons revolve. Where electrons revolves. Can anyone tell me another name of orbit?
Shells.
Shell. Next is another name of orbit is shell. Shell. Can you tell me why the name orbit, why the name shell? Orbit means revolve in a circular way, right? So that's why the name of the path is orbit. Are you getting my point?
Yeah, I am,
Yes,
sir.
sir.
And why the orbits are called shell? Because shell, you know that shell is a place where something hide, right? So electrons are hidden inside the orbit. That's why it is called shell. Are you getting my point?
Yes,
Yes,
I
sir.
am, sir.
Because electrons are hidden inside the orbit. That's why it is called or shell, right? Can anyone tell me how many orbits are there or shells are there?
It depends on the atom, right?
Just can you tell me maximum number of shell?
So four, right?
4. Okay. Can you tell me how many periods in periodic table?
Oh, uh, like 7.
7. So there are 7
Oh,
orbits. There are 7 period. There are 7 shell. There are 7 orbits. So next point, there are 7 period or 7 shell. So look at 7 shell, right? This is shell number 1. This is shell number 2. This is shell number 3. This is shell number 4. This is shell number 5. This is shell number 6. And the last one is 7. All are imaginary, right? All are imaginary. Let's suppose this is electron. So always remember each shell has specific energy. Each shell, you know that you have 7 shells. Each shell has specific energy. First shell has low energy. Second shell has higher energy. 7th shell has highest energy. As we move away from the nucleus, energy of the electron increases. Because as we move farther away from the nucleus, attraction of the nucleus decreases. Energy of the electron increases. Are you getting my point or not?
yes, I am,
Yes,
sir.
sir.
So each shell has a specific energy. That's why another name of orbit is energy level. Are you getting my point or not?
Yes.
Yeah, I get it, sir.
Okay, each shell has specific energy. Specific energy. Each shell has specific energy or level. That's why another name of shell is energy level. Another name is energy level. Another name is energy level. Are you getting my point or not?
Yes, sir. I am, sir.
Okay. Now look at the diagram again. Let's suppose if we want to move first shell electron to last one, which thing must be provided to the electron to promote it to higher energy level? Yes. Can anyone suggest me? Let's suppose we have electron in the first shell and we want to move this electron to lower energy level to higher energy level. So what thing must be provided to this electron?
Ionization energy.
Only energy, not ionization energy, only
Oh,
energy.
okay.
So give energy. Let's suppose this is energy. When you give energy, electron moves to higher state. So this is called ground state and this one is called excited state. This is called excited state. After getting energy, electron become excited and move to higher energy level. And this one is ground state. Ground state. So let's suppose this is shell number 7. 6, 5, 4, 3, 2, 1. Here n is equal to 1. Here we have electron. So energy is provided. Now electron moves to higher energy level. So can you tell me which one is ground state?
Ground state.
N is equal to 1 or n is equal to 7?
N is equal to 1, right?
N is equal to 1. So this is ground state.
Right. Okay.
And this one is excited state. So energy is required, right?
Yeah. It is.
Now, after a few hours, this electron or few seconds or sometimes few minutes, sometimes few hours, this promoted electron returns back. Now this electron returns back. So can anyone tell me when this electron returns back to its original state, where will be the absorbed energy? When electron returns back to its original position, you know that this electron absorbs energy to become excited. So when this electron returns back to its original position, it's what is your opinion? Where is the energy of electron? It is emitted in the form of light. Are you getting my point?
Yes.
The absorbed
Yes.
energy is emitted in the form of light. Light. Emitted in the form of light. And when this light is strike on the detector, you can see that we have packet of light. We have dark, this one, just like barcode. This is light, packet of light. This is packet of light. This is packet of light. Packet of light. Known as quantum. That's why another name of shell is principal quantum number. Are you getting my point or not?
Yes, sir.
Each shell has different quantum, different pattern, because they absorb different light, different emitted light, different principal quantum number, different light pattern.
Sir, when you refer to light patterns, you mean like you mean
Just
like
like barcode.
the thickness of barcode?
Light barcode means you have different fringes, right? Dark fringes or light fringes. It's a kind of pattern. It's a kind of pattern. Black and white, black and white, black and white.
Oh, okay.
Black and white pattern is called quantum.
Okay, got it. Okay.
Quantum is the packet of light. So I would like to write all this. Electron stay in normal energy level. This state is called, yes, this state is called, yes, anyone?
So ground
Oh,
state.
Ground
yeah.
state, ground state, very good. This state is called ground state. This state is called ground state. When electron absorbs energy, it moves to higher energy level. This state is called, yes, this state is called
Excited state.
excited state. Very good. Excited state. This state is called excited state. Next point. When electrons or when electron absorb energy, when electron absorbs energy, it moves to higher energy level. It moves to higher energy level. This state is called, oh, higher energy level. When electron absorb energy, it moves to higher energy level. This state is called excited state, right? When electron return to its original position, when electron return to ground state, it emits radiation. It emits radiation in the form of packet of light. Packet of light. Known as quantum. Known as quantum. That's why another name of shell is principal quantum number. Principal quantum number. Principal quantum number. Now look at the summary of this. What is orbit imaginary path? Imaginary path. Yes, can anyone tell me another name of this imaginary path? What is the
Shells.
name of the imaginary path? Shell. What is another name of imaginary path?
Orbit.
Very good. Orbit. Yes, another name. Energy level. Energy level. And another name is principal quantum number. Principal quantum number. Another name is principal quantum number. Okay. Do you have any question regarding orbit?
No, sir.
Okay. Now, next is orbital. Orbital. Yes. Can anyone tell me what is orbital? Yes. What is orbital?
I've got no idea.
Okay. Uh, my friend, now listen. This is my friend home. He lives in this home, right? Name of the friend is Usama. And this is Usama home. Usama room, sorry. This is drawing room. And the place where he lives is, let's suppose, Karachi. Now, listen carefully. Where is the maximum chances to find Usama? In Karachi, in home, or Usama room? Where is the maximum chances to find Usama? Yes,
Osama's room.
Usama room. So Karachi is orbit. Karachi is orbit where Usama lives. And Usama room is orbital where we have maximum chances to find Usama. Let's suppose Usama is electron. Let's suppose Usama is electron. Let's suppose Usama is electron. This is first shell. This is another shell. This is another shell. Here we have the electron. So electron revolves around the Karachi. Usama lives in Karachi. So orbit is Karachi. And where we have maximum chances to find this electron is called orbital. This is orbital and this is orbit. Are you getting my point or not?
Yes, sir.
Orbit is, so orbit is Usama room. Orbital is Usama room. and orbit is Karachi. So orbital is a place. Orbital is a place in orbit or within the orbit where maximum chances to find an electron. To find an electron. Are you getting my point or not?
Yes, sir.
Alhamdulillah, alhamdulillah. So orbital is a place where maximum chances to find an electron. Now, types of orbital. Types of orbital. So we have 4 types of orbital. Can anyone name this orbital? Do you know what are the orbitals? And how many types of orbitals? Yes. Mohammed, do you know?
No, sir, I've got no idea.
Okay, there are 4 orbital. First is s orbital, then p orbital, then d orbital, then f orbital. We have 4 types of orbital. We have 4 types of orbital. We have 4 types of orbital. So let's start from s orbital. S orbital. S orbital. Now, you know that Osama room has a specific shape, right? A specific design, a specific color. Similarly, S orbital, shape of S orbital is spherical. Shape of S orbital is spherical. Let's suppose this is your y-axis, this is x-axis, this is z-axis. X, y, z. So shape of the s orbital is spherical. This is s orbital. S orbital. S orbital. Next point. Each shell has s orbital. Each shell has s orbital. Each shell has s orbital. Next, s orbital has maximum 2 electrons. Maximum 2 electrons. So maximum capability of s orbital to contain electron is 2. S orbital contain has the capability to attain two electrons. Next point, S move away from the nucleus. Away from the nucleus, size of s orbital increases. Size of s orbital increases. Now, look at this structure. This is first shell. This is second shell. This is third shell. This is fourth one. Fifth. Sixth. And then 7. So we have 7 shell. So each shell has s orbital. This is s orbital. This is s orbital. Size of the s orbital increases. Size of the s orbital increases. Size of s orbital increases. Are you getting my point or not?
Yes, sir.
This is 7th one, right? Okay. So leave the 7th one, right? Just consider 6, right? So size of s orbital increases. As you move away, size of s orbital increases. Size of s orbital increases. Oh, here we have space. First shell, second, third, fourth, 5, 6, 6, 7. So size of s orbital increases. Yes, are you getting my point or not?
Yes, sir.
Okay. Now next question. Draw shape of the following orbital. Draw shape of the following orbitals. First is 1s, second is 2s, third is 4s. First, draw axis. x-axis, y-axis, z-axis. Now let's suppose this is 1s. 2s is double of 1s. And 4s is double of 2s. This is 1s, this is 2s, this is 4s. Are you getting my point or not? Bete, are you getting this point or not?
Yes, sir. Sir, should the drawing be to scale?
Yes, you have to draw.
No, sir. I mean, should it be to scale?
No need to, no need to, it should not be is on scale, right? It's roughly diagram. It's roughly diagram, right?
Okay.
Okay. Now second orbital is p orbital. Next orbital is p orbital. P orbital. P orbital. Yes. Shape of p orbital is dumbbell. First point. Shape of p orbital is dumbbell. Shape of p orbital is dumbbell. This is dumbbell. Next, each shell has p orbital except first shell. Each shell has p orbital except first shell. Next point. As you move away from the nucleus, just like s orbital, size of p orbital increases. Size of p orbital increases. Next point. There are 3 sub p orbital. So shape of p orbital is dumbbell. Each shell has p orbital except first one. As you move further away from the nucleus, size of p orbital increases. There are 3 sub p orbital. Px, Py, Pz. Next point. Next point, p orbital along x-axis is called px orbital. Similarly, orbital along y-axis is called py. Orbital along z-axis is called pz. Orbital along z-axis is called pz. Now, look at the diagram. This is x-axis, this is y-axis, this is z-axis. This is called px because this is along the x-axis. This is px orbital because it is along x-axis.
So shouldn't the vertical line be y-axis? You wrote Z.
Because you know that this is three-dimensional, right? So y and z axis are interchangeable, right? So you can set z axis become y axis become z, but x axis is always horizontal. Are you
Okay,
getting
sir.
my point or not?
Yes.
This is py. This is called pz because it is along the z axis. Can you tell me how many electrons do s orbital have?
So 2 electrons.
2 electrons. But p orbitals have 6 maximum electrons. So p orbital has maximum 6 electrons. P orbitals have maximum 6 electrons. Now look at the p orbital in it, right? Let's suppose this is px. Let's suppose this is only px. The size of px orbital increases. Size of px orbital increases. Now question. Draw shape of falling orbitals. Number 1, 2px. Can I write 1px? Beta, can I write 1px?
No,
No,
because
sir.
the electronic shell doesn't have the P shape.
Very good, because first shell does not have p orbital. So 2px, 4px, 2py, 3py, 5p orbital. Now first draw axis. This is x-axis, this is y-axis, this is z-axis. So we need 5. 2, 3, 4, then 5. So first one is 2px. Let's suppose this is 2px. Let's suppose this is 2px. So 4px would be double of 2px. Four px. Then 2py. This is 2py. Because along the y-axis. Then 3py. Slightly bigger than 2py. This is 3py. Last one is p orbital. P orbital means you have to draw px. This is px. This is py. This is py. This is pz. This is pz. This is pz. Do you have any question regarding p orbital?
No, sir.
Okay. Now we have d orbital, right? D orbital. D orbital. Shape and name are not in AS syllabus. You will study d orbital in A2. Should I explain or leave it for A2? Yes, my dear students, should I explain shape of the d orbital right now or leave it for A2?
Sir,
What is your Hmm?
Or I guess you could leave for A2.
Okay, good decision. Now next is E shell has E shell has d orbital except f orbital, except first and second.
Sir, is it okay if we can end the class right now because we have a class after like literally 5 minutes? I do.
Okay, 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 okay. So
All
we
right.
will we will do it on Sunday, right?
Yeah, please.
Okay. Do you
All
have
right.
any question?
No, not so far, sir.
Okay, we will start d orbital in the next class, right?
Yeah. Okay.
Okay. Allah Hafiz.
Thank you a lot, sir. Allah Hafiz.
Allah
Allah
Hafiz.
Hafiz, sir.
Allah Hafiz.